Hello and welcome to Soros Sir's classes. Today's tutorial will be on Econometrics. In case of any query, you can contact us on this number, and if you wish to know more about us, you can check in our website. So today we will be dealing with this question. So let us read the question first. The question is, prove that least square intercept estimator in the classical regression model is the minimum variance linear unbiased estimator. Okay, and the short form is given by MVUE. Okay, now let us start with the tutorial. So let the constant term, okay, so let intercept, so let the constant term be written as A is equal to summation DIYI, where summation DI and Y is equal to alpha beta xi plus epsilon I, and this is equal to A summation DI plus beta summation DI xi plus summation DI epsilon I. Now in order for A to be unbiased, so if we want the intercept or the constant term to be unbiased for all xi, we must have, these two conditions satisfied, that is summation DI is equal to 1 and the summation DI xi is equal to 0. So we will be considering the minimization of the variance. So minimizing the variance of our term, that is A, subject to these constraints, subject to these two constraints. So now we will set up the Lagrange, and so we will include both these constraints. Okay, so let us set up the Lagrange. So the Lagrangian is variance A plus lambda, this is the first constraint, plus lambda 2, and this is our second constraint, where we know variance of A is equal to summation sigma square, and this is di square. Okay, now let us move on. Now we want to minimize this with respect to the above, with respect to DI, lambda 1 and lambda 2. The n plus 2 necessary conditions are we will get the first order derivative. So let us, so del L del DI is equal to 2 sigma square DI lambda 1 plus, then the other one will be lambda 2 xi. Okay, this is first del L del lambda 1, which is equal to summation DI minus 1, and then next we have del L del lambda 2, which is equal to summation I di xi. So the first equation implies that, so I'll equate all these three equations equal to 0, then I'll get, so from, if this is say Roman 1, this is Roman 2 and this is Roman 3, so 1 implies that di is equal to minus 1 by 2 sigma square into lambda 1 plus lambda 2 xi. Okay, therefore we can write summation I di is equal to 1, we know this, and then which is equal to minus 1 2 sigma square into n lambda 1 summation xi into lambda 2. Okay, then so let me insert a page. So we have, and we know summation I di xi is equal to 0, which is equal to 2 sigma square bracket close summation I xi into lambda 1 plus summation I xi square this into lambda 2 bracket close. Now we can solve these two equations for lambda 1 and lambda 2, the above two equations, by first multiplying both the equations. So you multiply both equations by this factor, then rewriting the resulting equation as in this form. So it is n summation I xi summation I xi square lambda 1 lambda 2, the two equation we are looking for, these two only, these two value is equal to minus 2 sigma square and 0. So the solution is, lambda 1 lambda 2 is equal to n summation I xi summation I xi square minus 2 sigma square 0, and the thing is missing is the inverse sign. Okay, so now we can write as, note that summation xi is equal to nx bar. Thus the determinant of the matrix is, so the determinant of the matrix is n summation I xi square minus nx bar square is equal to n bracket open summation I xi square minus nx bar square, which is nothing but nsxx, where if you have forgotten, if you don't remember, then nxx is summation I n xi minus x bar square. Okay, so the solution is therefore this 1 by nxss, the same thing we will write once again. Okay, so minus x bar 0 into minus 2 sigma square 0. Okay, or we can write lambda 1 is equal to this by n divided by sx, lambda 2 is equal to and our di is equal to then summation I xi square by n minus x bar xi this simplifies. If we write the above will simplify. Summation xi squared is equal to plus nx bar square. So we have summation I xi square by n is equal to xx by n plus x bar square. Then di can be written as this, or in a more familiar form, di can be written as negative sign comes in front, this makes the intercept, which is nothing but this, equal to which is equal to y bar minus bx bar, which was to be shown. Okay, so I hope this tutorial on Econometrics was helpful. If it was, then please hit the like button, subscribe to our channel, and thank you so much for watching.